Hello, it's Keith here, and this is lesson 9 of the simple series of my 68000 assembly programming tutorials. We're going to be taking the bitmap example before where we got a smiley face onto the screen, and we're going to extend it and we're going to move that smiley face around the screen with the joystick. Now the idea of this is that you could use this as a sort of template for a little game of some kind, and I actually did this. This was the foundation for the YQuest game, which you'll be seeing later on, which uses this simple code and converts the YQuest game, which was originally a Z80 game, into a little Amiga game, as I say, using this code. Let's go over and have a look at today's code and see it in action. If I just get to the start of the source here and I just compile this up, and if I just turn off warp mode, and then I can start the program with W here, and here is the smiley face. Now I've got my little joypad here and I can use up, down, left and right to move the smiley around the screen, but if I get to the edges of the screen you can see I cannot go off the screen. So we've got some simple boundary checking here. Okay, so that's what we're going to be making today. I'm not going to go over in any great detail the code that was in the bitmap example because it's quite complicated and I don't want to repeat myself. So if you've not seen that episode, please take a look at that afterwards. We're going to focus on the joystick reading routine and the new code that's handling the movement of the smiley around the screen. So first we've got some definitions here of some registers that control the graphics here, because of course we need to turn on our graphics screen. Here we're connecting to the operating system to get a graphic screen. Here we're defining the screen layout. We're defining the copper list, which is the coprocessor commands which define the screen. We're defining the screen memory here, the palette here, the second palette here, which is used by the sprites, I believe that is. And then we've got a wait for VBlank, and then we turn on the screen here by enabling that copper list. Okay, now here is the start of the code that is new today. Now just before that we're going to discuss this code here. This is basically a modified version of the sprite code that you saw before for the smiley. The smiley is still there it is, that's the smiley, and there's a new blank sprite which is just a bunch of 0 bytes here which will clear the smiley off the screen. Now this code here you should recognize because it's basically the same as the simple series. It's getting the screen address using getScreenPos, and it's drawing the bytes of the smiley to the screen. DrawPlay uses the smiley sprite, DrawBlank clears the sprite off the screen. Now you've got wait VBlank here, which is used during the startup, getScreenPos, which calculates a screen position from an XY coordinate, and we've got this new function here which is read controls dual. Now this is going to read in the joysticks, and this is the sort of meat of today's episode. Let's have a look at it now. So we're going to read in the joysticks, and we're also going to read in the fire button, although this example doesn't use the fire button. Now the way we do this, we need to configure the direction of the port, so we're going to need to select it for reading for these two bits here. So we write this bit pattern here to BFE201 here, and that will select those two bits for reading. We need those because these are the joystick ports, you see. So we're going to read in the joystick 0 here, and we're going to load that into D5 first, and we're going to read in the second joystick, and then we're going to do the same again for the first joystick. So here's the one that's going to be used by today's example. So we're going to load in from DFF00C here, which is mouse port 1, which we're assuming joystick 1 is in. We would use this port for joystick 2. And then we're going to use this read controls dual, which will handle the directions and move them into something a bit more helpful. We're also moving the fire buttons into D5, which you'll see is going to be used later on. Now, these ports are kind of mouse ports, and so the data that comes out of them isn't directly usable for joysticks. We have to do some bit conversion here, and you can see here we're going to be doing that. So we've got horizontal and vertical data here, and we need to get a particular set of bits here, and these then need to have some logical operations done to convert them to a on or off direction. So we have to XOR bits 8 and 9 together to get up, XOR bits 0 and 1 together to get down. Left and right are bits 9 and bits 1 here, those are straightforward, and then the fire button we're taking from this fire here in this port that we read in here. So all of these shifts are just moving them around. We're then inverting them to match the format that my tutorials usually use, and we're just clearing all the other bits, setting them all to 1. So this will read in the joysticks quite conveniently, hopefully for 2 controllers. So if you want to have a go with that, you can use that in your own code. I did do another tutorial on reading the joystick, which used basically the same code as well. Okay, so that's how we're reading our joystick. You know, you'll see after the joystick code there is a RAM definition section here. We've got some pointers here that are used during initialization for getting the graphics library, and then we've got the chip RAM, and this is the RAM that can be used by the hardware, and we're defining the screen memory here. This is used by the pixels of the screen, 320 by 200 4-bit planes. We've got the copper list here. Now this is the coprocessor commands that handle drawing of the screen. We've defined 1024 bytes for that. And then we've got an X and Y position for the current player position and the last player position. We'll see those used later on. So we've got those and they will be used. Okay, so here is the start of our main loop here. And we're starting the player position as 3,32 here, X and Y position. And then we're loading a dummy value into the joystick. Now the reason we're loading a dummy value, you see, is that we're going to wait for a key to be pressed normally, but the first loop we want to show the starting position of the player. So we're skipping over the reading for the first time and we're jumping straight into the draw routine. Now the reading routine here is reading in the joystick and moving it into D3 here, which is our joystick directions, and we're going to test those later on. First, what we do is we back up the X and Y position, and then we clear the current player position off the screen, so the player is no longer on the screen. Then we process each direction, testing the bits up, down, left and right, and we're just adding and subtracting accordingly from the position of the player sprite. Now because of the format of the Amiga screen, it's a bit tricky to work with at the pixel level, so we're working in 8x8 blocks in this, which means there's some jerky movement, but this is only a basic tutorial, so I thought that was going to be enough for this example. So that's what we're doing there, and that's why we're subtracting and adding 8 vertically but 1 horizontally, because we're working in bytes across the screen. Okay, so next what we're doing here is we are updating the player's position, and then we're going to check if the player has gone off the screen. Now the top corner of the screen is 0, 0. Now if we go below 0, we will wrap around the word value to 65535. So we don't need to check the bottom limit, we just need to check the top limit, because we're effectively checking if the value's wrapped around. So the width of the screen is 40 bytes, so we're checking 40, and the screen height is 200, and the image is 8 pixels tall, so we're just checking the Y boundary there as well. If the position's okay, we jump down here. If it's not, then we're going to reset the X and Y position of the player here. And then finally, whatever the player position is, we draw the player back to the screen and we pause a little while for the next draw. And once we've done that, we jump all the way back up to here and we start the loop again, reading in the input and processing onwards. Okay. And that's actually all there is to it. So as I say, we've got a basic drawing routine here that allows us to read input and process it and then draw the result on the screen. And as I say, this did actually become a simple game in the YQuest example, which we'll see later on. So there we go. That's all we're going to be covering today. As always, you can get the source code for today's example from my website. You can just go ahead and download it. And as I always say, if it's any help to you, you're welcome to use it in your own code. You don't need to give me any credit. Do whatever you want with it. I really don't care. I hope you've enjoyed this. If you have, please like and subscribe, because there will be more Amiga content coming later on. Of course, I've also got a lot of other systems I cover, so you know, take a look around my YouTube channel and see if there's anything else that interests you. But whatever you do, I wish you the best in your programming, and I hope you have a lot of fun. Thanks for watching today, and goodbye.